Hello guys, in this video I'm going to explain how half wave rectification works. So what is rectification? Rectification simply implies converting AC voltage to DC. So our AC voltage for this course is 50 hertz, and that's the frequency 50 hertz, while the amplitude, which is the peak voltage, so we need to set the peak voltage. The peak voltage will be 311 volts. So, and the RMS of that is 220 volts. So we need a voltmeter to read the input voltage. So now the most important component when it comes to rectification, and that is a diode. This is the electronic symbol of a diode. So, and you need to connect it either in forward bias mode or in reverse bias mode. So either I connect it this way or I connect it this way, so it will work. It will what? It will work. It will work. But one terminal, one thing you must observe is one terminal. Well, I prefer to connect it in this way, but one terminal of the diode will be connected to the source, while the other terminal of the source will be connected to the ground. So I'm trying to make the video as explanatory as possible. Now we need a load resistor, that is a resistor to serve as load. That's the meaning of saying load resistor. So, and for that I'll be using 100 kilo ohms. Now, as I said, a diode is a semiconductor device that converts AC voltage to DC volts. So by cancelling the negative voltage, alternating current, it has a positive side and the negative sides. So let's use this voltmeter to check our output voltage. So we want to see what is going on. Let's see what is going on. So now, as you can see in the graph, or should I say and the mini oscilloscope, the mini oscilloscope. So at least it's helpful, it's very helpful. So you can see the green signal is the output voltage signal, is the output voltage taken by the voltmeter, this voltmeter, while the purple signal is taken by the input voltmeter, the voltmeter at the input. So as you can see, let me split it. So I've splitted the signal. As you can see, the purple signal is an sinusoidal signal, so it's going from the positive half to the negative, so positive 220 volts to negative 220 volts, while the output signal, which is our rectified voltage, is not going back to the negative signal. Is not observing it negative half, it's only positive half, and that's the work of the diode. So we've successfully converted our AC voltage to DC voltage using a diode. Yes, so with just one diode we have converted our AC to DC. So that's very important. So this is known as half wave rectification. So you can see the output, which is the green signal on the oscilloscope, is half. So it's half, it's not complete. So we also have the bridge wave rectification. We also have full wave rectification. So that's the three types of rectifications we have. So this is the first one. I'll also be doing videos on those ones separately. So I hope you understand this now. So there's also a concept in order to smoothen our output. So we can introduce another interesting component known as the capacitor. So the capacitor will filter this signal. So let me include that I want to know what is going on with the resistor. So introducing a capacitor now. So you introduce a polarized capacitor, and the meaning of polarized capacitor simply means a capacitor that has positive terminal and negative terminal. So let's increase the capacitance to 100 microfarad. Now you see, let's see the output. Let's see. So as you can see, the output, what is being read by our output voltmeter, by the voltmeter at the output. So you can see the output voltage is now constant. Yes, so you can see it rises and now it's not coming to zero. That's the work of the capacitor. It's storing charge, and when it ought to go to zero, the capacitor will release the charge it has stored. So in order to stabilize the output voltage, so it has filtered out the pulsating. So let me disconnect the capacitor, and you see now take a look at this. You can see the output waveform is pulsating. It's going to positive half and coming back to zero. But after introducing the resistor, the capacitor to filter it, you can see it's no more coming back to 0 volts. That's the function of the capacitor. It stores charge, and when the charge it stores is needed, it releases it. So when the purple signal is coming back to 0, which is the waveform, the diode has blocked it, right? Yes. So instead of when the voltage is coming to 0, the capacitor, the charges it has stored, it will now release it. So you understand, that's what is going on in the circuit. Now let me reduce the capacitance of this capacitor. Let's make it 10 microfarad and see the output. So you can see, so take a look at this. So you can see that there are little pulses. It's coming down and going up again, but it's not that clear because the capacitor is trying its best to smoothen the waveform. So that's good. Now let's reduce the capacitance. Let's try one UF and see what is going on. You see the voltage is coming down, it will rise again. It's coming down, it will rise again. So now when it's coming down but it's not coming down to 0, that's the function of the capacitor. It is storing, it is releasing the charge. So when it goes up, it stores more and release it. So now the capacitance of the capacitor also affects the smoothing capacity of the circuit. So if you want your circuit to the DC, because when you talk about DC is positive, you don't have negative voltage in DC. Now to make sure that your voltage is smoothened, you introduce a capacitor. Although yes, not only a capacitor can be used, we also make use of inductors. Yes, in inductors as well. Inductors is an electronic component that you can use. It stores electric charge in magnetic field. Capacitor stores electric charge in electric field. So as you can see, it has a positive charge. The capacitor has a positive charge and a negative charge. In fact, let's look what is going on with the capacitor. So this orange signal is what is going on with the capacitor. So the capacitor is charged. Now when it comes to 0, you see it's charged and discharging. Yes, so that's what is going on with the capacitor. So I hope you enjoyed this video. Please click on that like button, like, then subscribe to this channel, please. Thank you.